Take their seats. We'll get started for session number 2. Thank you, thank you. There'll be a break and a mingle session after me, I believe. So everyone will get a chance to get up and wander around and chit-chat and all that fun stuff. So, wow. This is my first time in London. And London has been very welcoming. I didn't know what to expect, but it's been great. My daughter's here with me, actually, not at the conference. She's actually touring London today. She said, I told her I'm doing a presentation today at 10, and her thing was, I don't have to go, do I? So she's actually getting a tour of Buckingham Palace. Probably, maybe less interesting than what I'm going to be talking about, but let's get going. I'm Paul Lefebvre. Can I speak louder? I can try. You keep hollering at me if I start to mumble again, but I will speak as loud as I can. So I'm Paul Lefebvre, and today I'm going to be talking about multi-platform madness, which is what it's like working with Xojo sometimes when you are working on all your projects. So some of the topics I'm going to cover today are the Xojo platforms, what UI you can deal with on different platforms, framework stuff, considerations to keep in mind as you are building apps for a variety of platforms, how you might share code. And then we're going to take a look at some example projects. We probably won't get through all the examples. I don't want to bore everyone with that. I actually have 16. I have 4 examples for all 4 platforms that are sharing code. And we'll look at a few of those and see how things are working there. And then we also have a hands-on session later after Travis's Android session where we'll dive into these in a bit more detail as well. So if you don't get to see everything you want right now, we'll look at them again as well. So as hopefully everyone here knows, Xojo is a multi-platform development tool and framework, and we create all the apps now, pretty much, desktop, web, and mobile. And as I like to say, there's a meme on the internet. It's called All the Things, or it has this weird stick figure holding up something like, it's always been my favorite meme. And Xojo does all the things, really. So let's talk about desktop first. It's been around, as Jeff talked about in his keynote, a really, really long time. 1998 is way, way back there. It's hard to believe how far ago that is. But Xojo started on Mac. And then in 2000, Windows. I'm pretty sure that's about the time frame. Might be off a year or so. But then Windows showed up. And then in 2005, Linux showed up. So those are all desktop platforms, and they showed up over time. And then that's kind of a pattern you're going to see with Xojo in general, how we keep building. It keeps getting better than it used to be. It does more than it used to do. In 2007, Intel became a thing on the Mac. In 2013, Cocoa became a thing on the Mac, and after many, many years of work. And then in 2015, more things started appearing. 64-bit, Raspberry Pi. This was because of the LLVM stuff that Jeff talked about. In 2016, your desktop apps started to be able to use high DPI displays, which were becoming more and more common. And then in 2020, Apple, as they tend to do, it put out another CPU. What is this, their 32nd or something like that? Apple Silicon became available, and your desktop apps can now be made with that. So a lot of changes over the years for desktop. And then here in 2022, the most recent thing that was added to desktop was the ARM capabilities for both Windows and Linux. So Xojo keeps moving forward. Jeff's theme of change is very apt, and you can clearly see it in a progression like here with the desktop, which is our product that essentially has been around the longest amount of time. Then we have web, introduced in 2010 with Web 1.0. And then in 2014, Xojo Cloud was introduced to make it much, much easier for you to deploy your web apps. And then in 2016, high DPI support was added. And then in 2020 was Web 2.0. So you can also see a progression of web over the years. Fewer years than desktop, but over the years, it also is continuing to advance and bring new things for you to use. Now mobile. First appearing in 2014 with iOS 1.0. Again, after many, many years of development. These things don't just pop into existence. Well, they do for you all in many ways. But, I mean, I don't even know when this project was originally began, but it was, you know, much earlier than that. In 2015, we quickly had to get 64-bit up and running for iOS because Apple made the decision that they were switching all their devices to 64-bit. In 2016, I kind of gave it this little code word here, but this was iOS 1.5, where we added a bunch of things, controls mostly, but some framework stuff to iOS that were never in the original release. So it beefed up the iOS support. It added some things like enhancements to the table, and I don't remember all the specifics, but there was some pretty significant chunk of new iOS features that were added then. And then in 2020, we did iOS 2.0, which was what you see out there today, which is the new API, the mobile API, the one that is, from an API standpoint, shared with Android. So that's how those kind of came together so that when Android comes out, you're going to be working with very much the same things. And then in 2023, as you heard Jeff say, Android 1.0 will be available. So let's talk a bit about user interface stuff. Now, if you've worked with Xojo on a variety of projects, how many people here make Xojo apps using more than one of the project types? All right, that's probably half-ish, so that's good. So if you've worked with a desktop project and you switch to web, or you start with web and you switch to mobile or whatever, there are different controls. And some of them are different, some of them are similar, and these are a good chunk of the ones that you see here. These are the ones that are pretty much the same or very close to it across all the different platforms. So you can see there's a button. Every UI that you see of some type has a button of some kind. So that's on all our platforms. And the button controls generally all work very similarly. That's probably one of the simplest controls, so it is able to work the most similarly across all the different platforms. Then you've got text field and text area, which are obviously used to provide input. These are similar across all the controls. They don't all necessarily have the same features, but they're very similar. For example, desktop probably has a bit more features. It can do things like style text that you can't do on mobile, for example. But for the most part, there's a lot of similar features that are shared there. The switch is another control that is very similar. Technically, that one's not on desktop, but it is on the other platforms. You've got your segmented button. You've got your slider. Date time picker for choosing dates. And although the control that you drag from the library functions similarly, that's an example of a control that can look drastically different depending on which platform it's running on. You get the canvas. Again, very, very similar and incredibly useful across all the platforms because it allows you to draw what you want. So that is a super important control to keep in mind when you're building apps across multiple platforms. Label, oval, and rectangle are nice to fill out the list, but obviously probably not used too much. Same with separator. And then you get the progress controls. HTML viewer is super handy in this day with so much content coming from the internet. Movie player, tables and list boxes. They're similar in that they're available for all the different projects, but they're also an example of one that can be very different across the various platforms. And then you have timer and image viewer, and more recently the chart. And then toolbars and tabs are also often available on most of the various platforms, but they can work a little bit differently depending on the specifics. So a lot of controls there that can be shared. And not shared, but you can see how they're similar and work similarly across the different platforms. But as I mentioned, each platform can have its own set of controls. And we don't try to shy away from that necessarily. If it makes sense that there is a control that's needed for a particular platform, and it only makes sense there, then we will provide it for that platform if we can. Ideally, we would want them for all, but sometimes it doesn't make sense, or it's not feasible right away, or for whatever the reason. So on desktop, there are some controls that are only available there. So you can see here something like a scroll bar, or the color picker, or the pop-up arrow, the up-down arrow, the disclosure triangle. Those are not really something you see on the other platforms anyway, and so they're only on desktop. Web has its own set of controls that are pretty unique to it. You get the link control. There's a map viewer control that is there. There's a file uploader control that probably wouldn't make a lot of sense on any of the other platforms anyway. There's a pagination control and a breadcrumb control, and those are kind of pretty unique to web app designs, so it makes sense that they're specific there. iOS has its own set of controls that can be a little unique. It has a countdown picker control. That's a weird little thing, but it lets you set essentially a countdown using a spinner type thing. Not really something you tend to see on other platforms. It does also have a map viewer similar to web. And then mobile has what's called a scrollable area, which is kind of a container that scrolls, so to speak. So you can put a separate container that has a large list of things in it, throw it in a scrollable area, and it allows you to scroll it up and down. Very important on mobile devices that are usually pretty tiny, and there's not a lot of room, so you do need to scroll around. Sharing panel, technically that might have some use on the other platforms, but right now that's a mobile thing. And then pop-up message is a kind of right now a unique thing on the mobile platforms, which is just a transient message that kind of pops on the screen, a little bit of text, and then it would fade away or disappear after a short period of time. Not really a control per se, but it is a UI element. And then Android pretty much has the same platform-specific stuff as iOS, as you can see here. The ones I've listed here, scrollable area, sharing panel, and pop-up message, those are all also on iOS. As you'll see as a theme as I go through things, you'll notice that Android, remember, and you'll hear more about this one during Travis's session, is version what? 1. So it won't quite have as many things as iOS does to start, although it technically, I believe, based on our analysis, is going to have more things to start than iOS did when it started. More controls that are available on different platforms but behave differently across them. I kind of touched on these a little bit. But on desktop, you've got the list box, which is, who hasn't used the list box, right? If you're making a desktop app, you've used the list box. It's the biggest, most complicated control. It's got the most events, properties, the most of everything. And it clearly behaves differently on desktop than it does on web. And then iOS and Android don't even have a list box control. They have variations of table, which is something that you would see on a mobile device, and that works differently. Desktop tabs, tab panel is a control there. Tabs are very common UI design, so that's a common thing there. But there's also one on web. It looks similarly, works similarly. But tabs on iOS don't really look or work all that similarly. The tabs are on the bottom, and they work a little bit differently. But ironically, tabs on Android seem to work a little bit more like you'd see tabs on web, for example. So although they all have the feature, they're not all necessarily exactly the same. And that's especially true of toolbar, which varies greatly depending on the type of device that is using the toolbar. Desktop toolbars are, at the top of the window. Web toolbars, I'm pretty sure you can stick those anywhere, maybe, but they're definitely at the top of the window also. iOS toolbars could be at the top of the screen, at the bottom of the screen is kind of maybe a toolbar. Same thing with Android, and they can have menus built in them and all kinds of different things that you expect for the platform. All right, so let's touch a bit on the framework. Now, the framework is the stuff that is essentially not related to the user interface. So, it's all the cool stuff. The stuff that lets you write your apps without dealing with user interface. So for example, I'm not going to list them all here. The framework is huge. But it's things like dictionary. It's a data structure in this particular case. That's part of the framework. That's available everywhere. JSON item is another thing that would be considered part of the framework. SQLite database is another framework thing, and all the database stuff, of course. All the math functions are part of the framework. The framework is a big thing. So much of the framework itself is just flat out shared across all the platforms. So the framework code is almost exactly used the same way, works the same way across all the platforms. You'll notice there's a little star there, because you see that a lot, but except for Android is what that star means. On Android, a lot of this stuff had to be recreated from scratch. There can be custom implementations of things depending on the platform, so that, talking to getting a folder item, for example. Obviously, files work differently on macOS versus Windows versus Linux versus iOS versus Android. So you're dealing with the folder item, for example, but under the hood there is all kinds of implementations for the various platforms that you don't ever have to see, so you can just deal with the single API. And this essentially allows it to, essentially it's bridging things off to the operating system to do what it needs to do that makes sense. Now, although the framework is the same across all the platforms by and large, there can be different behavior that you can see on the various platforms. So that is something to keep in mind. And examples of that could be perhaps, I'm thinking of something off the top of my head because I like to do that, so it's different every time if I ever do this presentation again. But say, thinking on Linux or maybe even Android, getting the modified date of a file, folder item, is not going to always work the way you might expect it does on Windows and Linux. I'm pretty sure on Android, one of those you can't set. You can maybe get it, but you can't set it. And that's just an OS limitation. And there's just little details like that that you may need to pay attention to if you're just trying to reuse framework code across your different projects. Special folder is a module that's in the framework, and this has a variety of paths to things that clearly are going to be different across platforms. So that's something to pay attention to. Graphics is something to pay attention to that can draw differently depending on platform. That could be related to aliasing, for example. One thing we'll look at in one of the examples in a minute is I wanted to make a library to draw playing cards on the screen that I could share across all our platform types. And I was going to draw the symbols on the cards, the suits, using a graphics path, because why not? Well, that worked great, except on web, which graphics path doesn't draw in graphics on web. It's a limitation of graphics there. So I had to come up with an alternative, code up my library so that it behaved differently on web, but exact same code would work on desktop and mobile. Clipboard is another example of things that can be different. On desktop, you have pretty much complete control over the clipboard, but web, not so much, and even less control on mobile. Worker is a framework item that currently is desktop only, for example. So if you were making use on that on a desktop app and you were moving a bunch of stuff over to one of the other platforms, you'd have to keep in mind that web is not currently an option for you to use there. And databases are an important one to keep in mind if you want to be designing your multi-platform app. especially if you've started from desktop, because desktop allows you to do a strict client-server application where your application can talk to a database server using a plugin of some sort, and you've got a direct communication there. The other platforms don't really want you to do it that way, especially mobile. So, and in some cases will do their best to prevent you from doing it that way. So you'll want to come up with a different design if you really think you're going to be wanting to share all your database code across multiple platforms. SQLite, generally you can use the same stuff everywhere. You can just connect to your SQLite database because that's not client-server, that's a local database. You can just connect to it, do what you need. And that generally will work across all the platform types. But say you wanted to connect to Postgres. Well, on a desktop app, yay, I just drop in the Postgres plugin, connect to that, use it the way I would want. But then if you've got a mobile app that wants to talk to that Postgres app, you don't have that way to do it. You would want to do something else. And the most common technique is you're going to be building a web service of some kind. And that means all of a sudden now, all right, well, I started with a desktop app that was talking directly to Postgres. Well, I'll need to use Xojo Web to build myself out a web service. The web service will talk to Postgres, and I will send commands to the web service to do what I need to do. And then my mobile app will now be talking to my web app to deal with the database. So now you're using 3 of the Xojo project types there to build your apps that you need. And the web app itself, if you wanted to build its own web app, could use the web service. That is its separate web app. Lots of flexibility there, but things to keep in mind when you're working on the designs. To help you out with some of these differences that you see between capabilities of framework things, at the bottom of the doc pages, there's a little header section that says compatibility. And in there, we try to note differences that we know about or things to keep in mind. You know, if you come across stuff and you're like, oh, I didn't know that, and I didn't see it in the docs, you know what you're supposed to do? Let us know so we can add it. As sometimes we don't necessarily know that there was a difference. You know, having worked on the Android framework for a while, I can tell you the Android docs do not tend to be very detailed about what things are going to do or how they're going to work. It's often you just get a couple lines of the syntax and call it and see what happens. And so sometimes we're figuring out stuff just like you are. So some platform considerations. Let's see, design-wise. Keep in mind with the desktop, it is very, very easy to have an app that has multiple windows, right? I mean, you see that all the time. Boom, boom, windows pop up all over the place. You're not going to have that capability on any of the other platforms. Desktops have way more screen area. I mean, even this laptop that I'm using here, 14-inch Lenovo, has a huge screen compared to what I have available on my phone. And I hate this screen. It is tiny. I can't do any real work on it. I have a giant 32-inch curved display on my desk so I can see what I'm doing. This is even too tiny for me. But you have a lot more desktop or screen area on a desktop app to work with. And when you're working on your other platforms, most of that goes away. So you've got to rethink what your design looks like. Desktops typically will allow you more access to the system than the other platforms will. So, and a lot of this is if you're starting with desktop, these are things to keep in mind. They might be just assumptions you're making or something like that. But you know, it's much easier, less so now than it used to be, but it's still much easier to access the full access to system features or whatnot. Whereas on mobile, you're locked in your little sandbox immediately. You can't access anything outside of it. Same thing with web, for that matter. And desktop also tends to have, relatively high performance for certain things, because, everyone uses the term desktop for these type of apps, but really, most people use laptops these days. Maybe people start calling this laptop or something. But desktops and laptops are often plugged in. Mine are plugged in. They have much bigger batteries, so they can, be more power hungry. So all of that can lead to improved performance. So keep in mind that sometimes you may need to think about something that is speedy enough on desktop, it might need to be looked at again on the other platforms. And when you're distributing stuff on desktop, you do have to be cognizant of some of the more modern things that are required. This isn't 1998 where you could just build an app and throw it on a floppy disk and give it to all your friends. Most of the platforms are going to want you to code sign in some way for best results. There are tons of app stores now that you can put your apps in should you desire, although luckily and nicely and fortunately those aren't required on desktop, which is great. Makes distribution a little bit easier. All right, so web design. Important thing on web is you have this concept of a session, because essentially with a web, desktop, you got one person that's using the app. The app is running, one person is using it. A web app can have one person using it, sure, but generally you want more than one person using your web app, and that's where the session comes in. So each person that connects to your web app, a new session is created, and that essentially becomes the context for that user that's connected to the web app. So if you think about that from a desktop app standpoint, stuff that you might be putting in, say, the app class of your desktop app, because it's global and needs to be accessible to the whole thing, probably make more sense to be in the session of your web app. Because if it's in the app of the web app, it's global to the whole web app and everyone that's using it. And that might not be what you intend. Another important thing to keep in mind with web is that it is highly asynchronous. Desktop apps typically are what's called synchronous. Do something, wait for it to finish, something happens. And you can wait, or you don't often wait, because things are pretty speedy on desktop. But web, you have to remember, is that your app is essentially running in two places. It is running on the user's web browser, that's place number one, and then it is running on your server, wherever it happens to be installed. So when you're debugging, both of those happen to be the same thing, your local computer. Things can appear pretty speedy. But as soon as you deploy, those things may be nowhere near each other. So you have to deal with them talking to each other. You have to deal with waiting. So if you click a button in a web app, that information has to be sent off to the server, processed by the server, and then the results sent back to the web app. So there's a communication process that needs to happen there that you need to keep in mind. And that's often called latency, that particular piece. But that's all related stuff that you often can easily ignore or skim over when doing a desktop app. And this results in performance. Again, with a web app, though, if it's running on a server, you can maybe get a pretty beefy server that's beefier than a desktop machine, so maybe some calculations could be quicker. You could spin off other processes to do some results for you to get back. So web apps can be pretty performant depending on what they need to do on the back end, but you do have to think about these things. When you're deploying web apps, got to worry about server management, of course. If you're using Xojo Cloud, well, you barely have to worry about server management. But if you're doing your own deployment to your own servers, you do have to keep that in mind. And I mentioned it earlier, I do like to remind people that web platform, the web project type, can be used to make web services in addition to web apps. And web services are great because anything can talk to a web service, and web services are pretty easy to make in Xojo. They don't require UI, you just have to implement the URL handled event on the app class and deal with the messaging coming in and send the data back. And you build a web service in Xojo, anything can call it, another Xojo app, another app in whatever, Python or whatever you decide. Web apps are a great way to leverage code and to share features and functionality across different platforms. So iOS. Tiny, tiny screen. This here is an iPhone 12. That's probably the medium-sized screen. But you don't have a lot to work with there. We do support iPads on iOS, so you do get a bigger screen there to work with. Although Apple's iPad messaging is a little weird. Some people are like, oh, it's a great desktop replacement. It's great for watching Netflix, so who knows. But you still have limited resources on iOS from a standpoint of accessing them, and also from a standpoint that the thing runs on a battery for the most part and doesn't necessarily have full network access all the time. Although that's becoming less and less of a problem. I do love here in London that everything is contactless. I think if you lost your phone here, you'd be lost. You can do everything here with just a phone walking around. It's amazing. Obviously, iOS is very locked down for app distribution. You're going to have to code sign, and you're going to have to go through Apple's App Store to get things distributed. I say have to. I mean, technically, you could use test flight to put an app out there. I think you can have up to 1,000 people use an app that's sitting in test flight, but you have to manually get them the information so they can pull it down and run it. So that is a way to distribute something if it's not needs to be widely available. Apple probably really frowns on using it in that manner. And then, of course, there's an enterprise setup where you can get an app distributed that isn't really in the App Store. But these are all something to keep in mind, and frankly, many times a pain to deal with. So, but those are the only distribution options for iOS. For Android, however, there will be a little different. So Android has many of the same limitations as iOS. A tiny screen, limited resources. Important thing that I think I briefly touched on earlier with my little asterisk, but remember, Android currently in its version what? 1, right, okay. Is a subset of the Xojo framework. So it doesn't have all the things that the full Xojo framework has. So for example, it is missing like regex. There's no regex currently on Android. But there wasn't on iOS for many, many years either. All right, so distribution on Android, though, is a bit more flexible than with iOS. You're still going to need to code sign. There's not really any way around that. But and there is a Play Store that you can put your app in. That's where the XDC app that Martin made is sitting. But you don't have to use the Play Store. Android supports side loading. And I don't know, since I've been out here, I think I heard some news that Apple, because of Europe, might be forced to starting to allow some side loading on their iOS devices. So we'll see what happens with that. But right now you can't yet. And side loading is just the fancy term that means you can build your own app and get it from outside the store and put it on your device and run it. In the case of Android, there are a couple settings switches you have to flip to turn that on, but it is possible, which is really, really nice. Makes it easy to distribute something that you don't feel needs to go into the full App Store, and should prove really, really valuable for consulting and building custom apps and things like that. So code sharing. Classes are a great way to share code across projects. And as we talked about before with the UI stuff, the UIs are all different between the platform types. So you're not going to be sharing your UI across platform types. You're just not going to do that. But you can share your other code across the platform types. And you can do that using classes. And a common technique is what's called MVC, Model View Controller. And in the case of Xojo, you can set that up using a class with whatever the layout happens to be, a window, a web page, or a screen, and then the event handlers. And then, so instead of stuffing all of your code in the events of, say, a window, for example, where if you built a web app, you're now going to have a web page, but your code is sitting in events on a window, you can't reuse that easily. But if you put that code in a class and then had the events calling the class, well, then your web page can do the same thing. And now that class can be shared across all the platform types. Of course, that means you're thinking ahead, perhaps, or you're doing a bit of refactoring. But that is a common technique. I tend to personally prefer the use of classes just in general with shared properties and methods over modules. I don't tend to use modules a lot myself for a lot of sharing or global things. Yeah, I would use classes. That's probably just a personal preference, but I find that works really well. Keep in mind the compatibility flags. On the inspector, there's an advanced tab. It's a little gear button at the top that you can tap, and there's some options there that let you select whether the class or some of its components, the methods or properties or whatnot, are available on desktop, web, iOS, or Android. And that allows you to create, have a special method that does some, web-specific things. And when that class is pulled into a desktop project, that method won't come along for the ride. Also, take advantage of the conditional compilation using target constants. So you can use #if code blocks and then the various target constants to block out chunks of code within a method that will run only on a specific platform. Now for sharing project items, you have a couple ways currently that you can do that. And this is where you want to have a project item that's used in multiple projects. And you can have what's called an external item. Jeff briefly touched on this in his keynote. An external item is a single project item that's saved out as either binary or XML and then can be used in multiple projects. I consider them a bit risky because of the reason Jeff mentioned, where if you change that external item, the change is reflected in all the projects that are making use of it, which means that you run the risk of making a change that could break any other project that's using it. You've got to make sure you go and test all those to make sure your change isn't going to affect it in some way. So I've never been a big fan of those in my own projects. They also, to me, aren't great with source control because you have to set up everything separately. But it can be done. I personally have tended to use a separate project for shared code and then manually move things around as needed. This process here that you're describing is going to be, when libraries are available, you won't need to do this manually thing. You would just have a separate library, and you would put the library where you need it, and then you use it, and sharing code will be super duper easy, and we are all super excited for that feature. But for now, you've got two solutions. Each has pros and cons, but I just wanted to point them out to you as options. I do like the internal one because it allows everything for the project to be in the source repo for the project. And then I tend to keep a separate project with my library, so to speak, and I would update that separately and move it around and update it in the projects when I was ready to do so. All right, so we have a little bit of time here to take a look at some examples. So we've got a lot of examples. And the main point of these examples is not to go through a lot of the specific code, but to show you some classes that are written such that just they are the exact same class in a desktop project, in a web project, in an iOS project, in an Android project, and that they work. All right, is that readable enough? Ugh. That is not great, is it? Sorry about that. Travis, we might need to tweak some sizing for when we do the hands-on thing. All right, so I just want to point out two classes that are sitting here. Now this simple example, let me just run it. This just has some JSON embedded in the app, and it's going to read through it, show the results. In this particular case, being a desktop app, it is showing in a list box. That is not really readable, so it doesn't matter what it says, but this was from a website that generated mock JSON data. In this particular case, it was generating gibberish for job responsibilities. So it says, Rain works on profit-focused analyzing data warehouse. Ugo works on inverse uniform secondary methodology. We should use this to generate the roadmap. So there's two classes here. There's one called staff, and there was one called staff detail. And these are processing the JSON that comes through here. So just quickly looking at the code that you probably can't even read. But you can see there, it's just, for a desktop app, it's just clearing the list box, getting the data back as an array, and iterating through it and adding rows. So the staff class is what's happening here. It's doing all the work. And you can see that on the constructor, it's just creating a JSON item, and then it has methods to pull out the particular values and return them as arrays. So that's all great. And with the way that is designed, if we say we look at the Android one, you can see the UI, I mean, in this case, it's simple, so it looks the same. It still has buttons on here. Instead of a list box, it has a table. If I look at one of the button code, I mean, you can see right there, it's got remove all the rows, get the stuff as an array, loop through and add it. And if you look at that one, I mean, it's pretty much the same. And because of the way that particular class has been designed. And we run that. All right, we can ask for the names, and we get them back in. They're shown in the list, and the same thing. So this particular app, simple as it is, most of the code is sitting in these classes down here at the bottom, and those are the same classes. These are exactly the same classes that are used in the desktop app. And it'd be the same for the web app, and the same for the iOS one that I can't actually run here because I'm using Windows, but web app has the same thing. It has the same exact classes. It uses them in the same exact way. So that's how you can start to building code that, for your multi-platform apps, doesn't need any changing. So that's a pretty simple example. Jumping to... And the technique is pretty much the same. I have another example here. We'll look at these at more detail in the hands-on, where we can actually see in the classes and how they're written and how the code looks, you know, in most cases is literally exactly the same code. This particular code here, this project here is going to use a URL connection. And this here is going to pull down posts from Mastodon that are using the Xojo tag. And I preloaded it with some data by, as they say on Mastodon, tooting. I tooted when Jeff started his keynote. So that's the first thing that shows up here on the result of my request from Mastodon. And again, this is using my class called Xojo that is a URL connection subclass, and just implements some of the events, in this case just content received, to get back content received gets back the result of the message that was sent to do the tag request. And then that result gets returned back to the window, which can then display it however it wants. So the other platforms can use that as is. So again, let's do with web this time. You can see Xojo is sitting here. That's the same Xojo. And all I had to change was the UI to be the way I want and call my Xojo. And it works the same way. All right, the last one I'll briefly show here, and again, we'll look at these all in more detail in the hands-on, is the draw cards one. This particular one is returning, is drawing a playing card, and not quite a real playing card. Oh, the ace not coming up first was good because, you know, it only had to have one symbol on it. The 5, this is actually not what a real playing card would look like. I was lazy. I didn't draw 5 spades. I didn't draw the 5 upside down in the bottom corner. I didn't put a fancy design, but, you know, That's an exercise for the reader. But this is, you know, and you can see here, this was the first example I thought of to do for this, because it reminded me of, to circle back to what Jeff was talking about in the keynote regarding BASIC, the very first full app that I made in BASIC back when I was just a wee lad was a game called High Card Wins that was essentially the game of war, where two people flip cards and the one with the highest value keeps both of them. And I made that using a random number generator that essentially, because I wasn't starting with a deck size, was like I was using an infinite deck of cards. So you could get back, you know, 300 aces in a row, or, you know, 50 aces before a king ever showed up, or whatever. It was clearly, you know, 12-year-old me didn't know what the heck he was doing. But now I knew that a deck has 52 cards. So when one is picked, it is removed from the deck, and you won't get another 6 of spades here until the deck is depleted. So there you go. I now can code a little bit better than I did in BASIC when I was 12. But I thought that would be a fun little example. So this particular example is dealing with graphics. And so this has a class down here, the card deck. And you can see this has a little arrow, probably totally not visible there on the screen. But this is technically an external item. I actually did this one as an external item. The other two I did using my copy method. And you can see here, the important thing to note here is this draw method that is drawing the card. I just passed in a graphics object. And so this is what is called on desktop and mobile, just calls draw and passes in the graphics. It's called from the paint event of the canvas. But on web, this one gets called. Notice they're both called draw, and the important difference is that if I look here on the compatibility flags, the one that uses web graphics is not enabled for mobile or desktop. It's only enabled for web and console. I didn't build console stuff because they don't draw graphics. But, and the one that is used, that uses just graphics, is enabled for desktop and mobile here. And I probably should have removed it from console, but I wasn't making console apps, so it didn't matter. So that means when I'm running one project type versus the other, this code won't be there, won't issue compile errors, etc. All right, like I said, we will look at those examples in much more detail in the hands-on session after the Android session this afternoon. All right, I want to save some time for any questions before we go on break. So, questions? Jim, in the back.
So, I have an iOS app now, and I want to do an Android app. So, there's two different project types now, right? At some point, am I going to be able to merge those into a single mobile project type, or how?
Okay, yeah, so Jim's question's regarding Android, technically, but I'll take it. I'll allow it. So he's noting that he has an existing iOS app, and maybe some of you do as well, and he's going to want an Android version, and right now they're separate project types, but will he be able to merge that at some point? And I think Jeff did briefly touch on this in the keynote, but yes, they are separate project types right now. That was kind of a requirement to get Xojo Android out this quickly. Waiting for the laughing. No. But anyway, yes, we have plans to get those merged into a single, what will be called mobile project type. And then essentially the mobile project type will have at the bottom left, like you see for a desktop, a checkbox for iOS and a checkbox for Android. And that is the plan. I don't have specifics for how we will be able to merge those, or if we will load one of those and then you have to fix it for the other one. We haven't gotten that far along yet. We need to kind of get Android out the door first before we can do a lot of work thinking about that. But that is the plan. That's all I can say for now. Jeff wants to comment on that, so I'll allow it.
A lot about planning, you know, if you do some forethought and
Right.
classes that we should.
Yeah. Jeff is attempting to do, as they say, the TLDR, too long didn't read, of my session, which is to say, plan ahead, put your code in the right places, and you're going to save yourself a lot of work in the long run, and that will apply also to dealing with iOS and Android projects. So thank you for that summary. Question? Yes, David.
Desktop and web have the tables work as in a similar way, but iOS is a totally different beast. Is Android still different again when it gets its list box?
All right, so we're talking about David's asking about the list box and the table on iOS, which are very, very different controls. And he's asking, well, what about Android? Is that also different than the iOS table? It is. Right now, it is completely different than the iOS table. We do have one of our tasks, once again, Android is out the door, is to come up with a design of a table that will work the same on both Android and iOS. Unfortunately, although they seem to have similar capabilities, the design under the hood from their framework levels is so different that that was just going to be, it needed a bigger amount of time to analyze and come up with something. But again, we do want to have that so that you don't have to have a different layout or some way to swap that around. So it's kind of a requirement before we can merge the projects also. Any other questions? If not, it's fun break time. All right, thank you.